Hi, everyone. This is the first presentation that we're gonna do for the training. For be able to, yeah, for the workshop and to be able to do the project properly. So, before we start, I want to introduce the team for those that haven't been to the COP meetings or the other meetings before. I'm Manfred Chirinash. I'm the president and the president, Danishi.
I'm the treasurer, Ignacio Jones. Well, Mr. Yanabu.
And I'm the secretary. Thank you.
Okay, and basically, we're just gonna, right now, we're gonna train you to, I don't know, so you can see what you like, what you don't like, and you can start learning the skills we promised you in the beginning.
So, orientation kind of workshops for you to understand.
So we can all be on the same page once we start working on projects.
Yeah, and before we start the announcement we wanted to make is that we officially got approved by Success, the main campus. So right now, we can, once we start the project, we can start asking for funds, different materials and everything from our side. So I'll leave it to Danny and Daniel for the presentation.
Thank you, Manfred. Okay, first, we want to present you the overall schedule of other workshops. So as you see today, we are doing the research one, and then the next one is going to be by Ian on Python and GitHub and on C++, one on Friday this week and one on the next week. Then there'll be engineering by Ignacio and also Arduino and then circuits. So we hope to see as many people as we can on all of these workshops. So we're going to present you today our workshop, the research workshop. I want to start by quickly saying what we'll have. So we will have 5 parts to this project, with the final 6, one being some hands-on activity in which we will discuss how we can apply what we discussed today, what we learned in context of the project that we chose as an organization. Well, particularly the Moon rover and the smaller project, the hydrogen propulsion system. We hope that we don't take too long on any of the first 5, so that the people who have to leave earlier for other classes, they can also participate a little bit in the activities. So first part is going to be, we're going to generally talk about what research is and how we do it. And then we're also going to share our tips on how to find some data here, how to filter it, interpreting it. But we're also going to have a quick section on that safety, and also lab safety. You talk a little bit about that and a little bit of useful statistic knowledge.
So to start with, what is research? Research is a cyclical learning process which comes from the scientific method, where there is a question or objective or observation. There's research, hypothesis, experiment, simulation, data analysis, and then an outcome. So what we want to emphasize today is that we're gonna use research in a 3-step process. We're gonna start with an objective. And then with that objective, we're going to do research about it and get an outcome.
Yes, so the scientific method is kind of our guideline on how we get from the very beginning, when we start questioning anything, all the way until the very end, when we already have some process completed, and then we reflect on what we have done. And the first step, which comes before research, is the setting of objectives. And I want to begin probably by drawing 2 circles here. One is going to be for our goals as organization and as individuals. And another one is going to be of goals of our potential partners and other people in the community who interact, well, specifically right now with the rover projects, our other aerospace things that we plan. So partner goals. And it's important that we set some sort of objective for ourselves and understand what we want, how we want it, and then understand, okay, what do other people in the field want it? So, for example, with our rover, well, we're probably gonna most likely look into NASA, what they've already built. They have their own projects regarding they probably have some failures, they have some successes. We want to know what currently do they have that is really well, and what do they have that's not so well. And this is basically this part, the intersection between the two circles. And if we find the sum goal that we can go for, that also is like NASA or other people in the Mars rover community or Moon rover community are like they want to achieve, by finding this balance, we can essentially, well, we can move on to research, and by the result of our research and all our other works, we can guarantee some degree of success because they will recognize our work and that'll be useful to them.
We'll be trying new learning experiences that they might have not thought of, different perspectives. And to get to our goals, we have to think of our objective, and that comes with significant questions, which means that we're gonna use questions that are gonna help us throughout our research and decide what are our motives. And we're gonna look for the partner goals, which they will probably have some previous knowledge of what they've done. And they might have also published some of their difficulties and struggles that they might have haven't been able to solve, or they were still wanting to explore. So once we combine these two ideas, we can both learn from each other, the potential partners and our organization.
Yes, and this step, if we do this very well, and I plan that on the hands-on activity, we did this also a little bit, we set some goals for ourselves. After we do this very well, we can go to the next part, which is the research.
So why do we research? Well, we do it so we can reliably obtain the necessary information we want, because sometimes there could be physical limitations where we cannot get the tools to empirically find the data that we want. So we can just search, browse for it. And it also provides us a way to have a common ground state for proceeding forward. That means that once we establish our research and get the information that we need for our projects, we can proceed forward by building upon that research, building after the foundation.
Research is on itself kind of a way for us to enter into the language that the professionals communicate with within the field that we want. We're going to see how all the smart scientists over there at NASA or other places that design these rovers, how they talk, what specifically they want, like how do they refer to their information. This is also part of research. Research is like a language on its own.
It's very broad. We're going to explain some of the different types it has. Okay, so research types. So I want to point out in the beginning that most of us do autonomously, like without thinking, the mixed methods research, which may include some of the examples we have here. Of course, there are many other types of research, but the one we mainly use in our daily lives is the basic research, which is, for example, you're using a search browser, the internet, just to read news. And it's information that you're not necessarily going to be using. It's just something that you read to inform yourself or entertain yourself, in comparison to the applied research, which is research where you have an objective and you use that objective to find the research, and then you apply it into your situation. And then there's also quantitative and the qualitative. So the quantitative is more numerical. That means that you're going to use numbers, measurements, and you're going to be able to process that information into charts and tables, graphs. And the qualitative is something more abstract, could be feelings, and then you can.
Yeah, well, qualitative is more about discussing ideas and relevance of those ideas, how they interact. I would say, like in the example of our, let's try hydrogen propulsion system, because I talked about the roof already. So hydrogen, like qualitative analysis would be seeing, okay, how popular is this fuel right now? What do other people think about it? How how is it perceived? Maybe we shouldn't go for it if people perceive it as something super dangerous. And quantitative analysis, it's very straightforward. It's like empirical calculation. Okay, how much space hydrogen takes up, or what is its efficiency, all these coefficients. That's quantitative.
Okay, and then the other type is the experimental, where you use an experiment itself to gather the information that you want. And that could be in a lab where you have a controlled environment to perform these experiments, and then you can get good, reliable results over it.
Yeah, a good example is experimental is when we act on some system. It's like a lab, we have some sort of set of chemicals and we add things, we see how things interact. Observational is we just look and we do not interact with the system at all. Like, for example, some urban engineer, he might look how the cars go and study how traffic works. Yeah, traffic patterns, for example, without manipulating anything on the road.
And yeah, another example would be just observing nature, how it's able to unfold itself. So, yeah. Okay.
Okay, so first of all, we're going to be sharing a little bit of some sources. A lot of you already know some of these sources. A really good source for all your articles is Google Scholar, and it filters a lot for you. And it's just like Google. And if you've used Google a lot, then you will definitely figure out how to use Google Scholar. It's very efficient. And JSTOR, the JSTOR, it has some things with access, the way you access it is can be a little tricky, but it also is a large
database of resources. Yeah. Okay, so we also need to use traceability and transparency. What we mean with that is being able to backtrace of how we got to a certain objective or a certain piece of research, which means that you also have to do citing, make sure that you include your source origins, and through that we can also have peer reviewing for transparency and making sure that we get all the details that we need in our research.
Also, citing also means checking the citations of the source that you are visiting. This can be helpful if the source that you are looking at isn't answering the question the way you want, but it's probably citing 100 other resources which explain it also very well. So look into what they cite, and if it is a good source. And yeah, you mentioned peer review. That's also something very useful. Readability is your ability to interpret what you've seen. And as I said before, research is almost a language on its own. And being able to understand is of course a very important part. Later, we're going to cover a little bit about statistics, and maybe that'll help you a little bit get into understanding what they mean. There might be some confidence intervals that it's hard to understand. You can always look that up, and yeah, that's very important.
And the last part is that we have to check for research is the formatting, and this can include using the proper syntax and diction. So that would mean being organized on it's similar to readability on how you're able to express information that you gathered, and being able to allow other people to understand it and yourself later for reference. This would also include like formattings from the MLA and APA.
SVA, yeah, these are also kind of certain languages of language rules. And if you know how to navigate them, you can easily tell where the data came from. So this helps you with citations.
It's like logical association.
So I want to share the useful tools that I've been using in the past, and they have helped me immensely. First one is Google operators. And actually on the next slide, I have attached an image of some famous operators. So if you type in Google and you say for, then the result is on with these keywords. You can use and see all of the keywords. You can put something in quotation marks in order for all results to have that, to have this what you type, because keyword, yeah, because sometimes you type something into Google and it gives you millions of results, but also millions of these results just don't work for you. They are not specific, they just, like the Google just forgets what you wanted to see. And if you put it in quotation marks, he will filter that it has to have some mention of that. You can put site and then colon. And then you only do site queries only from, for example, Facebook. And if you're looking for someone that like particular on Facebook, you can use that. The one that I use most frequently is file type. And this is super helpful to me because you can, for example, set that only the PDF files are going to be showing to you on your search results. I have personally used that in the past when I wanted to find out someone else's email. And I know that there are resumes or maybe there are like projects they worked on and then they left their email on some of it. And I don't know how to find it on the World Wide Web. And I just type out that PDF and only the PDF results show up. And this is very useful. And later in the presentation, you will be able to see more of the operators. You can look into it. I highly suggest you do that.
You can also filter by date. So you want to get the latest of information. You can set it to be after the year 2024 starts, or it could be between an interval or of an era that you want to.
Yeah, you can also do that in Google Scholar, if I remember.
Exactly. So
reverse image searching. This is something when you already have some kind of information and you want to trace it back to the source. When you go to Google and you go to images, you can drag and drop an image and you'll find the source of that image. This can also help you a lot. And lastly, you probably heard about it, archive.org and Wayback Machine. I have used it a lot when I wanted to access a website that has already, that doesn't already exist because the owner of the website just doesn't pay for it anymore. Yeah, it expired, yeah. And if I want to see what they had on that website, but it was like deleted or they stopped paying for it, they went bankrupt, I can go to Wayback Machine and see how it was in the past. This has helped me a lot, and I suggest you look into it.
but one other point to mention about archive.org is that they have a whole library of, whether it be like movies, it could be videos, it could be the books, and also scientific articles, even radio and the clips from the radio, they even have that. So they have a whole set of things that you can look into for free with an account. Okay. So another important point is compiling the data, which means abstracting the research that you obtain and being able to set it up in a way that you can use it properly and efficiently. So what we can do is, if you're running out of time or just doing a quick list, a quick sortation of your data, you can make a list. Or if you have more time and you have a bigger project with more people, you can set out mind maps and diagrams.
Mind maps is something where like you have some goal in the middle and then you have like some lines project to it and then they connect to some other ideas. And this is how you sort information, basically. Compiling data, what we're talking about specifically is sorting that information for you to later navigate because you can also get lost. And graphs, figures, you've probably done a lot of those in your other courses.
So yeah, the point is to break down the problem into simpler pieces. So you can have a better way to approach it and different perspectives that you hadn't seen until you visually have set it up. It could be very simple or very complex. It's just a matter to work with.
Yeah. Here we've attached a couple examples of what me and Danny
Yeah,
did
it's an experiment.
in the past. Here I had a physics experiment. Here he had a
So, yeah,
color
it was-
bar graph.
Yeah, and this one was a bar graph where I was studying light pollution here in Costa Rica, and I did I took pictures of this night sky, and then I created a program where it analyzed the color variation, and I sorted all the colors by averaging the colors through a grayscale variation, and then you can see all the different parameters that I was able to gather.
Yes, also about interpreting information. Research is also understanding what it is. So you have to be sometimes familiar with things like box plot. This is a box plot, right?
Yeah.
So like here's the median, this is the minimum, this is the maximum. this is what he had. And you probably know a lot from your other courses how to do it.
Yeah, there's different types, pie charts
Uh-huh.
and,
And the one I had before is just a simple table where I record one result against another. And I've later remember I assembled like a graph and then I did a regression line analysis. We can do that in Excel. By the way, does everyone here know how to use Excel or tools like that? Okay. All right, we're thinking if we can do some sort of also other like
short
workshop or workshop on
or tutoring.
anything like that, if
If
someone wants to
needed.
learn to use it, yeah. So any suggestions on workshops will be welcome.
Okay, so the next topic is computer safety. And this is how you handle your computer and your digital devices. So one point is, for example, not to click on suspicious links because your data can be stolen, and we don't want that for our organization. We want to have the best standards and set the organization up for success.
Yes, if you go on the website and it asks you to like, oh, click this and click this link, I can click it, like probably you should go off that website. Just from experience, I'm saying probably half of these links are very bad.
So yeah, when you don't know if a website is it's safe or legit, you can use Google Safe Browsing. It's a website where you can just copy the link of the you want to use of the website, and then you paste it into Google Safe Browsing, and it analyzes if that website is secure, and that can help you detect if it's bad or not.
Also, antiviruses, if your system has a antivirus, don't turn it on. It's very useful. Credentials, do not enter any of your passwords anywhere. I think we know this, right? That like,
Try to use credentials that are longer. They have like capital letters. They're more alphanumerical, as I would say, because otherwise people can if they find your password in the database after like from a database that got leaked, all your passwords can be easily tracked down, and you wouldn't want that. In fact, our organization has a policy where every year we're gonna be having to change the passwords that we're gonna use.
yes. And about plagiarism, you've probably heard about this. We'll go very quickly over this. If you are taking information from someone, it's just better to cite it. If you are using an AI, you either cite it or you don't use it. This is how it works in most of our works.
Yeah, so if you use AI, you would you would cite give the prompt that you use for the AI or the co-pilot, and then you would use the result that it gave you, or in some way paraphrase it and credit it.
Okay. Well, we'll wrap up quickly with lab safety and statistics so we can get on the hands-on activity because I know some of you have to get soon. Protective equipment. As an organization, we have to follow all the guidelines that you have. So if you had a chemistry course and you heard about all lab safety, we're gonna have to follow all of those. So lab coats, safety goggles, gloves, like within the context of what you're working with, other equipment. This is everything that you follow in your typical maybe chemistry course you're taking on. We're also gonna have to follow it if we are gonna have to use the lab.
We included this in research, and because we need to know what are the tools that we're gonna use and what we're gonna need. For example, the gloves, in some cases, there's some reactions that if a substance contacts with your glove can be reactive and turn into fire, for example. So yeah, just make sure to look if you're doing an experiment, what are you gonna need, and research the properties of the elements or from a reaction. So we also have a list of simple things not to do if you can. It would be not bringing food and beverages, and of course not fooling around. You gotta be serious when you're in a lab, because you don't know if an accident can happen, and we want to reduce all the chances for that to happen, because otherwise that would affect the reputability of our organization, and we want to be a good organization. Yeah, so also not bringing cosmetics and perfumes because of the same reason that there could be a reaction and a gas that could be released and it could react with the perfume or the cosmetics. And oh yeah, I forgot to say to not bring contacts if you can, because that the same concept can happen. And always wear your PPE for safety.
Okay, let's quickly go over statistical, I guess, good habits that you can have. This will help you later this will help you when gathering data and later compile it. So I'll start with measurements and units. Everything that you measure, you have to know which units you're using. One of the most common mistakes when it comes to physics, in my experience, is when I don't know, I'm calculating the width of the muscle, and I forget and what is centimeters, millimeters, which unit I use. Sometimes you can see, okay, if it makes sense, I can keep I can sometimes forget something and it's gonna be fine. But sometimes it's not okay to forget which units you're using. Plus, there are imperial units, there are the SI units. If you're measuring for some reason in inches, you should probably convert to something more standard for all
Metric system.
the metric system, yeah. And a good habit to generally have is to take multiple measurements. If you're doing some experiment, just have multiple trials and record everything and then take averages. And also when you're measuring, you have to keep track of significant figures. It's about precision specifically because if we measure something with two significant figures of worth of precisely, and then later we get a calculator output which has 15 digits after the zero, after the dot, then we cannot be that precise. We can only be as precise as we set ourselves to be.
And then we also have correlation and causation, which is trying to distinguish what a variable has a cause and effect relationship with another one. And this is important because not everything causes something. Like some things are related, but they're not necessarily impacting each other. There could be another factor that could be affecting both variables in different cases. And another thing to point out is the confounding variables, which is
Confounding variables it can be anything that affects your measurement and you can know about it or don't know about it. One common strategy of valuing common variables is to have random sampling. And by selecting samples at random and doing things at random, you make sure that even if confounding variables act on the system, they still do not take effect that on the overall trend. Okay,
we reach the time
we reached the time for the activity. We're trying to keep this the overall presentation a little shorter. So right now, we invite you to have a big discussion. Let's talk about the moon rover because we have decided about 2 weeks ago on this project and we are yet to begin on it. So today we can begin talking about the Mars rover. So anyone, what do you have in mind as an organization? What should we do? What should we research? What should we look into?
So, I mean, the short activity, I think we have planned is, so if you're interested in something about a moon rover, you can look into it. So for example, if you're interested in the wheels of the moon rover, you can right now, I don't know, look into the designs of the wheels or look what are the materials it's made of or things like that you can take into account. Even the properties of the moon or the environment that the moon rover will be. So we can say that some of the materials of the moon, like if it's gonna be if the floor is gonna be hard rock or if it's gonna be soft, you have to make a design for the wheel that can manage things.
Yeah.
And this
The research. Yes, Ian? Okay. Yeah, so let's maybe begin, let's quickly talk about this, because before we do research, we have to know what we want to do and what NASA wants to do. Has anyone seen anything recently regarding the moon rover? Do they know anything? Do you know where it can go for that?
I've heard about, like wheels that you guys are talking about, that they have to be a malleable material, but it can't be too hard or too soft, right? Because it does have to adapt a little bit to the environment. And it can't be, it has to be an airless tire. Because if, if you punch a wheel, there's no way you can fix it. It's not like you can call your local AAOD and get that.
Yeah, and airtight, you said, yeah. So this is how we can like begin looking into that. So this is about the wheels. I have personally seen how like the way you have to control whatever rows, this was particularly for Mars rovers, but when like the signal goes then and back, it takes 8 minutes. You have to design it to be like slow, and you have to design a good communication system with it, right? Because it has to move slow, and if there's a rock and there's like an 8-minute delay between everything, then this has to be an issue. So maybe look into communications with this is like communication on like another planet, communication to the other planet. So I'm writing here about
Some aspects.
some aspects, yeah, of the road that they have, what they're probably working on right now, what we should research about. Anything else?
Yeah, in particular, I like the idea of the communication because that means that we would have to design a rover
Anything?
that is gonna be resistant to like unpredictable conditions. Like if there could be wind that suddenly hits into the moon rover, and the rover could be like in a cliff or in a steep part. So we have to find a way to make a rover that perhaps responds to the environment without the necessity of communication.
Okay,
Yes.
I have a question regarding that.
Go.
So, and then I might be missing something, but how would wind affect the moon rover?
How would wind affect the moon over?
Oh, well, say like in a steep, I think I overshot it, but I mean like other factors, like there could be a sharp rock.
Okay, so you're talking more like the physical, not like.
Yes, yeah,
that,
because
'cause-
there-
Okay,
yeah,
yeah, that's
that's right,
like,
yeah,
how
my
would
bad,
wind
that's
affect
right.
like that? Okay, no,
Physical.
I might have missed it.
The point is that we should design a rover that can respond to its environment without having conflicts or being dependent of communication.
You have like some sort of AI backup system,
Yeah.
security system.
AI
Yeah.
backup system, yeah.
Yeah, I would like to research on like the energy source of the rover, like.
Energy source.
It's like battery powered, solar powered.
Yeah.
So energy,
So the cameras, having a good camera to see.
Sensors, yeah.
sensors, camera. Also to bring everyone up to speed. Does everyone know here what a moon rover or Mars rover is? More or less, have they seen them yet? Because
We
some
can
of
put
you-
an image. Like, look it up.
Yeah, we can look up an image if it isn't too difficult for you.
Wait, because I know that at least when it comes to sensors and the cameras, eventually they do end up getting dirty. And even when it comes to like the energy sources, eventually solar panels, they also end up getting dirty. So it comes to a point where the rover can't be used anymore because all these panels and everything is dirty. So
Yeah.
you
The
have to
maintenance.
like ideally have some sort of maintenance that it auto maintains.
Agree.
That's all.
Yes, maintenance. Yeah, nothing will last forever, and part of like it's like on one ongoing thing, designing something that lasts long. So if we're gonna design like a mover, we're probably gonna look into how we can make sure it lasts like longer than the ones that already or has some like aspects that already has, but maybe a little better, lasts a little longer, or consumes less energy. Ask answer from the. Sure. What else? So. Someone talked about AI, and I was thinking about an AI system that can basically figure out its terrain. And based on that, self-navigate, because as I said, like, it takes 8 minutes approximately for communication to Mars. Maybe to Moon is gonna be a bit better, but still, it's delayed, and the rover signal is very slow, partly because of the communication delays. So designing an AI system, like machine learning, coding, this is also like workshops that we'll be having. We can do that. So AI or like program that
Yeah,
the
it could al-
self-navigation.
it could also be mechanical, and or there could be, the coding could just be a loop that checks the maintenance of if all the properties of the moon rover is running properly. So it would like check
Yeah,
if
so
the,
it's like-
if the wheels are up, they're good, or like the speed of the rover, all those parameters would be saved. We have to have a way to save that.
Do you have anything to suggest?
Are you able to change the screen?
Yes, okay.
Okay, which one do you, do you workshop?
This one. Okay, so we're gonna try to put an image of a rover here so that people can see it. These machines, they're quite big. They get like rusty over time. Yes, they're also hard to land there, right? So one part is, this is more for us. How do we get it on, like, how do we get it there? How do we connect to someone who can, like, put it out there on the moon, right? So transportation.
You mentioned for the landing, or the, maybe even the design of the rover itself, so that if it overturns, it has a way to turn back, or in the moment of landing, maybe that it doesn't have like, okay, it has to be set in these specific four wheels, maybe that it's much easier to set back to zero.
So you said overturning, right? Like a beetle that just fell on its back. right?
Yeah. So that it can flip back up.
Can I look up something?
Cause I remember,
sure.
I think it was like.
Okay, can you
one-
show Yeah,
The,
wait, can I open it?
there was
It's
this.
over here.
No, but how can I use the browser?
That's the browser.
Oh, but then how can I control? Can you look up?
The moment that it lands, it has.
Okay.
If it lands differently, it's gonna flip over and then all the
Right,
like.
and then you
buttons
stop.
Yeah, like I remember seeing like some device which is like almost like a big balloon, like
Yeah.
many different balloons, and it like bounces multiple times and then like
Can you
opens up.
see it?
Also, yeah, like cheaper alternatives. Also,
really good at
to like make this.
I wanted to explain the wiki.
It's like safer.
Yeah.
Use very like huge jets to propel like upward to decrease your acceleration. And that probably
Like
depends
the
on
real
the cost
real
of
quick.
like the landing and overturning.
Yeah, so I don't know, an idea I had for like the rover, some of the materials that we can do, they call like oxidic materials, where they're able to, both they're flexible and durable, and they can stay stable in different configurations. For example, it could be turned burnt like this, like a circle, it could pop out, and then it could pop in and even close. So we could try a lot of different things for the materials, and we'll explore, we see.
Yeah, like,
I've seen some of these with like the designs of like moon colony.
yeah, especially if you need
Like a dome.
like lightweight material that is like cheaper, it's like airtight. We'll probably have to look into some structures of materials, research into that. So does anyone else want to add any? I don't think we'll have that much time to do actual research on these topics today because most of you have to go to another class at 2, right? So you,
20, so we have like 15 minutes.
15 more minutes. Oh, wait, that is some time. Okay, so anyone wants to add anything else? Do you have any suggestions?
Okay, I'll jump in. Here, when you imagine a rover, like the one we showed before, what do you imagine it's gonna do? It's gonna either explore, it has a purpose, it has an objective that we have to base the research on. It always has a goal. Like no space mission will be done if it doesn't have a concrete study and background and a goal that will benefit like the industry itself. So to jump in the moon rover designs that we have right now is the idea. We are basing ourselves in the need of construction in the moon, right? Everybody knows about the idea that we want to colonize the moon so humans can eventually go live in it. Sounds cool and all, but there's a lot of implications that if you research, you will find out that it's almost impossible, if not like really, really complicated to do something like that. Not because if we go there, obviously it's not sustainable for us, but all the materials, the soils is different. And how will we know that? It's only if we research. An example, did you know that the surface of the moon actually has water, a lot of chemicals that come from the cosmic wind, and it actually acts like sand. But if you put something really hot on top of the sand, of the lunar sand, it would turn to lava. So that we can investigate and research it so we can use, oh, well, if we get this lava, if we heat it up, in a sense, we can start making concrete in the moon without using any implication here on Earth. So the idea of this is to not only find the goal and the specific question, but to also try to find a solution to the thing. And like, because there's always hidden details and facts that we usually don't know. An example I'll say about the other project. Did you all know that with water, if you put in a little spark voltage, you can actually make hydrogen, and it's not that difficult. And it's actually, you can see every day in most of the cars that have a fuel cell. And it's something that we use day to day, but because we don't research, we don't investigate it, we usually don't know. And we just see it and, oh, okay, that's that.
Yeah, so also another idea that I came up with was that I read some papers that NASA had published about ice cores, and they wanted to explore the composition of Mars. They said that with ice cores, they can see like what type of materials there's underneath on the ground, and that can help build technology with that purpose in mind. So the ice cores themselves are also used here on Earth, and what they are, they're like cylinders that people extract from the ground, and they're usually done in like the Arctic and Antarctica places that are really cold, and even in mountains. And once they extract those tubes of ice, they can see the air bubbles that are stuck in between the ice. And then that can allow to do carbon dating and exploring some of the past that happened, the different ice age, things like that. That would also be, that could also be applied on Mars. However, nobody has been able to do that because the Mars rovers themselves, they cannot dig like a tube underground. So that could be something we could implement, or things like that that maybe have not been able to be accomplished as of yet.
Manfred said something super important, and I want to say it again. I said that in the beginning, but if you don't have a goal, then no space mission is possible. So, for example, we have to look into what goal NASA has set, and this is also not even a NASA. This is like a global goal that we have as humans here. What do we want to get there on? So we are going to land on the moon, and so what are we going to do? So let's see. Okay, do we want to do colonization? We have to see what maybe we can do some qualitative analysis, seeing how often is the idea of colonization. Do we want this, or maybe instead they want to go from direction of colonization? Maybe they want to just bring materials from one to here. Maybe they want to mine it. And if they don't want to colonize, but maybe mine instead, we have to come up with different machines that instead of analyzing samples and bringing them here, instead they just completely extract them and bring here, so we prosper here. This is a very important detail. So this is the beginning of all research, and I wish we had a little bit more time to like look into that. But of course, we would have to come also a bit more prepared to hear. This is designed for now as a workshop to just give you some information on how to get started on these.
I don't know if anybody has a question regarding the project itself, the rover, or the research part of it. In all the projects we're gonna do, we're gonna go through a process of first we investigate. Well, we're gonna talk about it in the other workshop. I'm gonna tell you a bit of how space missions are proposed, planted, and eventually led to go to space. But every single space mission and project has to start with research. Then it goes through, well, to say it better, every single space mission starts really, really big and starts smalling down and specializing itself little by little throughout the entire process. So the idea here is not that in the beginning we research to have a definitive idea, but we research to contribute to the idea of the project, to like mold it in a way that we can work it out here. So, well, I don't know if anybody has a question regarding a bit more about the idea we have of the moon rover, like what we're gonna do, or in the research part of things.
I have a question. So you guys always said that any project should start with an objective. What is your guys' objective with the development of the rover?
With this rover,
Yeah, so like in general, what is your objective with the rover as a project? Not the objective of the rover, but the objective of the rover project.
okay, so firstly, the objective of the project itself to do it here is not only because it's a cool project, it's something that is basic and that we can use to get more experience for later projects. But if we develop the idea of the rover here with the main objective for the rover itself is that if we eventually develop and build it, we can send it to the moon and the rover will be able to construct small buildings, blocks, and make structures in the moon without the need of a human. Why do we need that in here? Obviously, it's very unlikely that we're actually gonna send it to the moon. But doing it here not only proves that this is possible because we can test it out in sand and a lot of things that can impact the industry here with different applications, not only for making glass, but we can actually grab, let's say, bags of sand and we can put it inside the rover. And if it works with sand, it's gonna work on the moon. But with the sand, we can make like structures, small ones for here. They'll help a lot towards like, let's say, buildings and stuff like that on Earth.
To answer your question a little bit more directly, as to like why specifically moon rover, we had many project ideas, and this was a democratically elected choice that we do the moon rover.
Right.
Yeah, and of course, we have been planning to do like, okay, we had multiple options, we had to choose one. And yeah, it's about proving that it's possible from within here, as Manfred said, and we had to choose a project, and we chose specifically the moon rover by the majority vote.
Well, yeah, no, and I mean, I voted on it because I thought it had applicability through various
Yes.
topics, right? But my question was like, okay, so if you guys proposed it, was it just because it was something cool and everybody is working on it, and then it had the potential to later be applied to something else because it had an applicability through a wide degree of topics, or just because it was something somebody proposed and you just decided to?
No, this was initially one of my projects. I presented it in a competition. It was good. I mean, I did not win. But with this idea, if we eventually develop it, it will have not only an impact on the aerospace field with constructions in the moon, but it can also make smaller impacts here on Earth with constructions, with the study of behavior of sand and different,
Robotics.
yeah, exactly, robotics. And it has a like wide range of topics. And let's say the rovers, like the wheels of the rover are something really, really special. As in space, the wheels we use here won't work there. So by being here, we can study, research all the ideas about how we can make a proper wheel that will not only work for our rover on Earth, but in space too. And if we do something like that, we can maybe give a change to the modern wheel. We can maybe even design something better than a car wheel or something like that.
Yeah, and to add on to that, people can, advance more in our project, we can even publish like a scientific paper. And then people can read that paper and apply that to wheels that people can even use in, if we have like cars in Mars, for example, they could do a similar design. They can get inspired based on the rover and some of the ideas that we published. That could be used for other purposes
I don't know
in
if
space.
that answered your question, kind of.
Okay, what's your question?
Like in what part of territory that we have here in Earth? Could you like try this type of wheels to know if they could work like on the moon? Like what's the actual like texture of that sand?
Okay,
I mean, you're
That
saying
sand?
it won't work here in the world, but how will it work in Mars? I mean, how will
Okay.
you try it?
so with the research I've done before, in the moon, the lunar regolith is not sand, but it's dust, basically. It's a mixture of like a type of dirt, cosmic wind, chemicals. But the closest we can relate it here is to sand, because sand and dust, if they are like really accumulated, well, sand is already a bunch of little specks. And dust also behaves really similar, as the dust in the moon is not only the cosmic wind, but it's rocks, iron, a lot of different minerals that are present in the moon's surface. So if we compare them, they won't be exactly the same, and the behavior of them won't be exactly the same. But it's the closest comparison we can make here. And if it works here, we can say, okay, this works here. So yeah,
Similar behavior.
yeah. So we can adapt the little changes from the sand here on Earth to the moon's soil, to the lunar regoliths, for it to work in the different scenarios. And it's basically just to explore and study it.
Also getting like a little bit out of the design itself, because I'm pretty sure if you guys try and try and try, maybe some will be the right texture and you guys will get the right design. But what about the material? It would be like the same thing as here on Earth, or what do you guys think should?
Okay, so with the wheels, that's a really good question, because the wheels actually here, we can just make a small Wally kind of track that goes on the rover. But if you actually investigate, that is really inefficient and requires a lot of energy. So by studying like airless wheels that work here, they will most likely work on Earth. I mean, on the moon.
Yeah, most likely air, our wheels don't work there because there is, we design wheels here regarding to the atmospheric pressure that we have here and like the material we use. The atmospheric pressure is completely different there. And it's gonna be a disaster if we use the same wheels like here on there, just to give you some context.
Yeah, so basically it's similar to the sand and the lunar regoliths. We make it here and then we say, okay, the areas we design here is working perfectly. Then we can adapt it to work on the moon. I don't know if that answered your question.
Yes, it does.
Okay, no problem. I don't know if anybody has any other question. It can be anything about the project.
We also have a little other project, the hydrogen propulsion system, right?
Yeah.
So if you have questions about that, and Manfred also in particular has had any